Today I'll be talking about metamorphism, what is metamorphism, the types of metamorphism, and the movement of materials in metamorphism. Metamorphism is the alteration of minerals and textures of a rock by changes in temperature and pressure. Contact metamorphism is the alteration of rocks close to the contact of a cooling pluton. A pluton is an underground igneous body which once cooled and solidified is termed as a pluton. Regional metamorphism occurs in a very large area in response to increased temperature and pressure. We should all bear in mind that the change of a rock from its solid state occurs in different geological settings. Some types of rock alteration, such as weathering, are generally separated from metamorphism. As you can see in slide 3 and 4, when you have a body of magma intrude within the earth, it's important to note that it requires sufficient heat and melt. It requires sufficient heat to melt the surrounding rocks and cause assimilation of heat with the surrounding rocks and also the magma chamber. But often there isn't enough heat to actually initiate the melting, but there is enough heat to change the chemical composition of the surrounding rocks through metamorphism, and that's termed as contact or thermal metamorphism, unlike regional metamorphism, because it's only the effect of temperature that is being released and the pressure stays the same. And as you can see, if you imagine the magma chamber as a wall from this diagram, you can see the blue portion of it represent the zone of contact metamorphism, and this will surround the chamber, and that zone is called metamorphic aureole. These different shades of blue reflect the metamorphic grades, and that's an indication of the severity of metamorphism. So the rocks that are closest to the magma chamber will be the ones that are most affected by the change in temperature, and so they will have the highest metamorphic grade. As we all know, in regional metamorphism, rocks that form closer to the margin of tectonic plates, where the heat and pressure are greatest, often differ in their mineral and texture from those that form further away. In slide 5, during metamorphism, we observe the movement of materials such as the release of atoms in an unstable mineral grain, the formation of nuclei of the stable minerals, and of course the movement of atoms to the nuclei.
An example of metamorphism in Australia would be the Broken Hill ore deposit. Broken Hill is located in the midwest of New South Wales on the Broken Hill Block, a small portion of the Curnamona Craton. The Broken Hill ore deposit is a sedimentary exhalative deposit, also known as a SEDEX deposit. The Broken Hill ore deposit would have started off as a river delta, accumulating many layers of silt and sand. Around 1,685 million years ago, during the Proterozoic, hot geothermal fluids moved through all of these delta sediments, enriching them with various sulfide minerals. Much later, during the Delamerian orogeny around 460 million years ago, the Australian continent collided with the east coast of Australia, which at this point was a separate island. The two land masses pushed up against each other, crushing the Broken Hill block between the two parts of the country. This placed a massive amount of pressure on the craton, metamorphosing, folding and shearing the sulfide-rich sedimentary rocks into lead and zinc-rich sulfide clasts. The pressure and heat was so great that the non-ore-bearing rocks were turned into a very high-grade gneiss. The ore minerals were folded into a boomerang shape, pushing the high-density minerals into the thin centre, while causing the less dense minerals to accumulate on the thicker edges of the ore body.